Okay, good day, family. Good day, family. So today we'll be focusing on the type of reactions, which is grade 12 work, but we'll be focusing on what the type of reactions that involve what organic compounds. So for today, guys, reminder, we have three types of reactions in grade 12. The first one, we'll just be looking at them in just the generality for today. We know that we have what? We have addition reaction. That's our number one. And then number two, we have substitution reaction. And then last one is what? Is the elimination reaction. I repeat again, we have three types of reactions, which is the addition reaction, substitution reaction, and the elimination reaction. Now, with that being the case, we will be focusing more towards what the addition reaction just for today. Now, here's the tip, just my 2-cent tip I would like to give you guys. This is a 2-cent tip. You can take it or throw it away, or you can use it. It's all up to you. Now, these two types of reactions, these two, meaning the addition reaction and the substitution reaction, they cannot take place. They cannot take place. They cannot take place. So they cannot take place without what? Without what? An alkene. So for grade 12 work, the addition and the substitution reaction, they cannot take place without what? Without an alkene being part of the what? Of the reaction. Meaning, whenever you see any reaction of grade 12 in organic chemistry topic, any reaction that involves what? An alkene. I repeat, any reaction that involves an alkene in the organic chemistry topic, it has to either be addition or substitution. Guys, actually what? Let me give you a tip. If an alkene is a reactant, definitely your reaction is what? If an alkene is your reactant, your reaction is actually what? It's actually an addition reaction. That is just my 2-cent tip. If an alkene, in any type of reaction that you are dealing with, if your alkene, it is your reactant, it will become what? It will become an addition reaction. And then if your alkene is the product, then the reaction is what? It's an elimination reaction. It is an elimination reaction. I hope it makes sense so far. Can I just wipe the board, because I'm going to be focusing more today, not on all of the types of reactions. I will be focusing on what? On the addition reactions. I will be focusing on the addition reactions, guys. Let me just wipe this. So now, reminder, I said all addition reactions have to involve what, guys? All the addition reactions have to involve an alkene. So we're going to be starting with just a basic alkene for ourselves. So every reaction that I'm going to do today is going to be involving what is this alkene. So the first one, I'm going to start with the type of addition reaction. The first one, addition reaction. I'm going to start with its hydrogenation. hydrogenation. Okay? So what is a hydrogenation reaction? What is a hydrogenation reaction? Addition of hydrogenation reaction of addition. We are going to be adding hydrogen, which is H2. So we will be adding what? We will be adding H2. So our job is that we'll be adding H2 to an what? To an alkene. So let's look what we are talking about. I am going to add, what is this? I'm going to have this compound. So this is the compound I have. What is the name of this compound? The name of this compound is prop 1 in. So now we have, what is this? We have an alkene. That is the first one. We have an alkene, which we are adding hydrogen gas to it. So it's an alkene that we are adding a hydrogen gas to. So now, because of this reaction, we have to get rid of the what, guys? We have to get rid of the double bond. So now, hydrogen gas is not a really strong what compound. So in order for it to get in here, reminder, if it's hydrogen gas, what's going to happen? Hydrogen gas will have to separate. It will be a hydrogen atom. It will be a hydrogen atom. Now the situation with this one, guys, is what? Is that now it has to enter into what? Into an alkene. Now there is a vacant space. Where is this vacant space? The vacant space is here, guys. Is that this product is not what? Saturated. If it's not saturated, meaning what? There is a volume of area. This is the area, guys, I'm talking about. There is a volume of area where there's a vacant space where our hydrogen atoms can what? Can bond with our carbon atoms. So what's going to happen? One of the hydrogen gas will bond with what is this? With this hydrogen, with this carbon atom, and then another of it will have to bond with what? With the carbon atom. What will it produce? It will produce what? An alkane. This is what it will produce. Now this is what happened. Now what actually happened, guys? What happened is that the space which was vacant, which was here, is now being occupied by what? By the two hydrogen atoms that we added in this thing, which is regarded as what? As the hydrogenation. So because now we have a double bond, this one had to enter. Now the space which was vacant is now being occupied by the hydrogen atoms. But because hydrogen atom, guys, it's a very weak atom, what is going to happen? It is going to need what? A catalyst. Which catalyst is it going to need? It's going to need either a platinum, lead, or nickel. So this is the reaction condition. So it's going to need a catalyst to help it to break what? It's going to need the catalyst to break what? The double bond, because the hydrogen gas or the hydrogen atoms will not be able to what? To break the bond between the two carbon atoms because of the what? Of the polarity of the carbon atoms. So this is the first reaction which we regarded as what? As the hydrogenation. Any question? If you have any question, do not forget to type it in the comment section, or you can text us, or you can even reach out to our social media pages. So this is the first reaction which we regarded as what? As the hydrogenation, guys. So let's go to another one. This is the first addition reaction. Now, okay, I'm going to go to the second type of addition. Reaction number 2 that we're going to be focusing on. The second one that we're going to be focusing on, again, it's what is it? This one is also an addition reaction. It's what? It's hydration. Hi guys, for me, you don't even need to understand physical science with this one. Everyone knows the word what? Hydration. Hydration means what? Addition of water. Or let's say you are drinking water. We know that if you drink water, we are saying what? You are hydrating what? Yourself. So this is a hydration reaction. What does hydration reaction meaning? Means what? We are going to add water. So in this reaction, we are adding H2O. We are adding water, guys. Why are we adding water? Please reminder, I have said it already. Addition only involves alkene. We are adding water to an alkene. There is no reaction in the organic chemistry reaction where you add anything to what? To any other compound except what? Alkene. We are only adding to alkene. There will never be any reaction of organic chemistry where you add something without involving what? An alkene. So let's go again. Let's say we have H. So here's your reaction. Now we are adding water. We are adding water. Now, with that being the case, this one again is what is going to be addition. We are adding what? We are adding H2O to the compound. Now let's break down what? Let's break down H2O. H2O, guys, when we break it down, if we break it down, it's going to give us what? Is that we are going to have a positive hydrogen atom and what? And hydroxide ion. So these are the two things that are going to what? That are going to add into our product. Now we have a Markov-Kov's rule. Markov-Kov's rule says what? Markov-Kov said, if you are having what? If you have an alkene and you are adding what? You are adding water. The hydronium ion, which is this one, he said the hydronium ion is going to what? It is going to bond with a carbon with the least number of hydrogen atoms. I repeat again, Markov-Kov's rule said what? He said, if you are reacting or adding water to what? To an alkene, the hydronium ion is going to, or into hydroxide ion, is going to be bonded to a carbon with the least number of hydrogen atom. So what does that mean? It means we are going to add these two ions to what? To this alkene. But the question is, where between this carbon and this carbon, which carbon is H plus going to, or which carbon atom is OH going to? Now, because of this, he said if our hydronium ion or our hydroxide ion goes to the carbon with the least number of atoms, that product will be regarded as a what? As a major product. Meaning what? It does not mean it is the only product. When he says it's the major product, there will be multiple products being made from there, because the hydronium ion will have two options. But if we follow Markov-Kov's rule, it will give us what? The major product. Major product means what? The product will be made in more quantity than the other products. What is going to happen? He said this OH will go to the carbon between these two that has the least number of what? Of carbon atoms. How many carbon atoms does this carbon have? Guys, it only has what? One. This one has what? Sorry. This one has what? Has one carbon atom, while this one has what? Has two carbon atoms. So he said what? He said the hydroxide ion will go to the one with the least. Which one has the least number of carbon atoms, hydrogen atoms? It is this one. Meaning this one will come to this one, and then this one will bond with this one, producing what? This is what it will produce. It will produce H, C, H, 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 but now it's OH with C, H, H, and then H. That will be our product, meaning it will move from what? From an alkene to what? To alcohol. So if we move from an alkene to if we move from alkene to alcohol, we are actually what? Adding water. The whole process is called what? Hydration, guys. The whole reaction will be regarded as hydration. Now, what are the reaction conditions? What are the conditions that are needed for this reaction? We actually need what? A concentrated sulfuric acid. What will the concentrated sulfuric acid act as? It will act as a catalyst. Its job is simply to what? To speed up the rate of the reaction without itself being part of the reaction, or by simply what? By simply lowering the activation energy of the reaction. Any other question? So this is reaction number 2, which is addition reaction that involves alkene. Any question? If you have any question, do not hesitate to ask in the class, or if you have any other question, you can simply comment or say anything, or even reach out into our DMs. We'll be able to answer you. Now we are going to reaction number 3. Now we are going to reaction number 3. So that the reaction that I drew right there, guys, is regarded as what? Is the major product. So can I wait? Let me not just pass that statement. Reminder: what kind of products are going to be made? This will be the first product that is going to be made. C, H, H, not C, not H, C, which will be H, 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 then this will be O, H, then this is H. This will be regarded as what, guys? This will be regarded as the major product. Meaning maybe inside the container of the product, 96% of the product will be this. This is why we call it what? A major product. Another product will be what? Will be H, C, H, H, C, H, H, then C, H, O, H, then H. So this one will be regarded as what? As the minor product. What does this mean when we say this is a minor product? Meaning out of 100% of the product that will be made, maybe 4% of the product will be what? Will be the minor product, adding to what? Adding to 100%. So when your teacher in class says this is the minor problem or this is the major product, he means both of them will be made, just that this one will be made in more quantity than the other product. So I hope it makes sense. To save time, let's go to another reaction. Another reaction will be number 3. Reaction number 3 will also be addition. Like I said, we're only focusing on addition reaction today. Right now we'll be adding what? Br2, or even sometimes Cl2. So those are the only 2 that we are going to be focusing at. Now we have what? Remember, addition reaction has to involve what? An alkene. So we have C, H, 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 C, H, H, double bond, H, then H, then I made a mistake here. So that is an alkene where we are adding Cl2, or it can be what? It can be Br2. What is the name of this reaction, guys? The name of this reaction will be regarded as what? As this will be regarded as halogenation. So I repeat again, the reaction will be regarded as what? As the halogenation. Meaning, what is halogenation? We are adding what? 2 halogens. So now, with that being the case, what are the reaction conditions of this one? Now, what are the reaction conditions of this one? What are the reaction conditions of this one? Now, because chlorine has high electronegativity, guys, and even bromine, they have really high electronegativity. So in order for them to bond and be added to what? To this one, they won't require any heat, and they won't require what? They won't require any catalyst. They are strong enough. It is a compound that is strong enough to what? To break the double bond on its own and be able to add itself inside what? The organic compound. So no conditions. So this one has no conditions, guys. No conditions on this one. So now what's going to happen? Reminder, we have Cl2. So what's going to happen? Then Cl1 minus is going to break, and then Cl minus is also going to what? Is also going to break. So meaning what? These 2 atoms or ions will themselves go to this carbon atom, and then the other one will also go to what? To the other carbon atom. What will they produce? They will be able to produce H, C, H, H, C, H, then it will be Cl, which will be what? Will be H, then it will be Cl, which will be what? Which will be H. So the vacant space, meaning what? The vacant space that was here, the vacant space that was here, these 2 atoms or elements will go and bond with these 2 and break what? And break the double bond, making it what? It was not saturated, but now it is what? It is now saturated. So now what is the name of this one? Remind that the name of this one was what? Was prop 1 in. And now the name of this one is now what? 1,2 dichloropropane. Making it what? Making it moved from what? From an alkene to what? To a haloalkane. What type of addition reaction is this one? The type of addition reaction is halogenation, which is an addition reaction. I repeat again, for this one there are no reaction conditions. Why? Because chlorine gas, with its high electronegativity, it is able to simply add itself inside the alkene without assistance of any of the, what is this? Without assistance of a catalyst. I hope it makes sense. Now I'm going to the last addition reaction. I'm going to go to the last addition reaction because now the time has really went. I'm trying my level best not to waste any of your times now. Now the reaction number 4, which is the last one. Also this one is still regarded as what? As the addition reaction. Now the addition reaction is the last one is what? Is the hydrohalogenation. So the last one is the hydrohalogenation. Hydrohalogenation means what? We are going to add a hydrogen with a halogen, or which is hydrobromination, this one, or HCl, which is regarded as that one, as the hydrogen chlorination reaction. But it can simply be called what? hydrohalogenation. So first one, remember, addition has to involve what? Addition reaction has to involve alkene. So this is our alkene that we are going to involve. H, 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 then H. So what is the name of this one? The name is prop 1 in. What is the homologous series? This is our alkene. Functional group, obvious, hydrocarbon, organic compound that consists of only carbon and hydrogen atoms only. So now it is a question of which one are they going to involve in this one. So between these two, what are they going to involve? They are going to, let's say maybe they involved what is hydrochloric acid, which is regarded as HCl. Now what is going to happen? Now what are the reaction conditions? The same as the one we just did right now. No conditions. Now what are the no conditions? Why doesn't it need any catalyst or any heat? The reason is because of what? Of this chlorine, guys. That is the reason. Chlorine has enough what? Electronegativity or enough pull force to break, what is this? To break the double bond on its own. It has enough pull force to break the double bond. It won't need any acid, any catalyst, nothing. It will be able to do that on its own. So what is going to happen? Now the Markov-Ikov rules comes again in this one. It says what? The chlorine will bond with the carbon with the least number of what? Of hydrogen atoms. How many hydrogen atoms does this one have? The middle one, guys. The middle one has how many hydrogen atoms? It has 1 hydrogen atom, while this one has what? Has 2, while this one has what? Has 3. But our main focus is the carbon atoms that are double bonded. So this one has 1 hydrogen atom, while this one has 2 hydrogen atoms. So what is going to happen? The hydrogen chloride will break itself, making it what? To be Cl minus and H what? Plus. Now what is going to happen? The chlorine atom or chlorine ion will bond with the carbon with the least number of what? Of hydrogen atoms. So this one will have to choose between these two, which one does it want to bond with, and it will choose this one according to Markov-Ikov's rule. Why will it choose this one? Because it has the least number of what? Of hydrogen atoms, and while it bonds with this one, it will form what we call a major product. Now what will be our answer? Our answer will be what? Will therefore be what? Will therefore be H, C, H, H, C, H. Now it will be Cl bonding with what? With H, H, then what? Then H. This will be regarded as the what? As the major product. The name of that one, what is the name? The name will be 2-chloropropane. Homologous series haloalkane. Functional group, it does not have a functional group. So that is our final type of addition reaction. So to remind you again of types of addition reaction, what are the types of addition reaction? Number 1, addition reaction involves what? Involves hydrogenation, which is H2. We add H2 to an alkene. The second one is what? It's hydration. Hydration is what? We add H2O to an alkene. And then number 3, we have what? Halogenation, which is adding what? Which is adding Br2 or Cl2 to an alkane. And then the last one is the one we just did right now, halogenation. Hydrogenation, which is adding HCl or HBr. The condition for this one, the condition for hydrogenation, it's what? It is platinum, lead, or even nickel with a bit of what? Of heat. Guys, it can be mild heat actually. And then hydration needs what? It simply needs what? Concentrated sulfuric acid is what is the reaction condition. So everything that you see here is all incomplete, nothing more, nothing less. So I hope everything made a bit of sense. Then thank you very much, and I hope to see you guys next time. Have a great night. Don't forget to subscribe. Don't forget to follow our pages at YouTuber Life Coach. We are officially based in Bethlehem, working at Tisefang. We work every day from Monday to Saturday from 3 till 5, and then on Sundays we work from 12 till 3 o'clock, teaching mathematics, physical science, tech maths, life science, and accounting. And we are looking forward to adding more subjects, as we have also added mathematics into our lives, into our maths lit, and we are ranging from grade 8, 9, 10, 11, and 12, and we have few for grade 4, we have few grade 5s, and we have few grade 6, as it has not been officially been declared as part of our grades, but we do actually help also the lower grades. Thank you very much. Have a great night. Bye bye guys. Sharp.